I want to show you how to change the base of the logarithm. Right, but before that, if you are new here, please subscribe to my YouTube channel and share my videos, like them as well. Right, so we are going to start with this very important result. Right, if we want to change log x base a to base c, we simply write log x base c, the new base, over log a, the old base c, the new base, right, like this. So this is the important result that we'll be using throughout. Right, for example, express log 8 base 3 in base 4. This is very simple. We are going to rewrite this as log 8 base 4 over log 3 base 4, like this, according to this important result. Right, then we can simplify the numerator here. Log 8 base 4, we can simplify this. We can evaluate this. The actual value of log 8 base 4 is the power to which we can raise this base 4 to, for us to get 8. So that power is 3 over 2. So we can write this as 3 over 2 over log 3 base 4. So we can simplify this and write our final answer as 3 over 2 log 3 base 4. As simple as this. Right, let's move on to our second example. Right, solve the equation. So if you look at these bases, we have x here and 4 here. The bases are not the same. So first of all, before we simplify, because we can't simplify, we can't use the laws of logarithms to express these two logarithms as a single logarithm, while the bases are not the same. So we are going to make sure that the bases are the same. So the choice is ours. We can express log 16 base x in terms of log 4, in terms of base 4, or this one in base 4 in terms of base x. Right, so let's express this log 16 base x in base 2 at the same time expressing log 32 base 4 in base 2 as well. Right, so we are saying log 16 base x is equal to log 16 base 2 over log x base 2, like this. Then if we simplify log 32 base 4, there's no need of expressing this one in base 2, since we can evaluate what's the power that we raise 4 to for us to get 32. It is 2,5, right? So log 16, this one in the numerator, log 16 base 2 simplifies to 4, because 2 to the power 4 is 16. So by definition, this one simplifies to 4. So we end up having this one. So the next thing is now to solve for x. Let's take this 2.5 to the right hand side, where it will be subtracting. So it will be 2 minus 2.5. So it will be minus 0.5. Then let's make this, want to make this x the subject of the formula. So let's clear the denominator. At the same time, making log x base 2 the subject, we find out that we multiply by log x base 2, then we divide by negative 0.5. Then we find log x base 2 is equal to that one. Right. Then 4 divided by negative 0.5, we get negative 8. So log x base 2 is equal to minus 8. And by the definition of logarithms, this 2 raised to the power minus 8 will give us this x. So by the definition, we are going to rewrite this in the next form. So x is equals to 2 to the power minus 8, which simplifies to 1 over 256. As simple as this. Right, let's move on to our next example, the third example, which is the last example. Right, solve the equation. Right, likewise in this case, this one is in base 5, this one is in base x, so we can't simplify before we change the base, before we make sure that these logarithms are in terms of a common base. Right, so let's express this log x base 5 in terms of base x. So let's leave these two out. Then log x base 5 is the same as log x base x over log 5 base x, like this. Right. Then from there, we can see, as we can see, according to this other important result, log x base x is 1. So this reduces to 1 over log 5 base x. Now, we have log 5 base x here. We also have log 5 base x. So to make our life easy, let log 5 base x be equal to something, for example, m. But don't use x because we already have x in the system. So let log 5 base x be equal to m. So instead of writing this, it will be 1 over m. Then instead of writing this one, it will be m, like this. Then let's clear the denominator and simplify. Right, this is now a quadratic equation. Let's take this 3m to the left hand side. We find out that m squared minus 3m plus 2 is equals to 0. Let's factorize this one and solve for m. If we factorize this quadratic expression on the left hand side, we find m minus 1 factor of m minus 2, and this is equal to 0. So the roots are 1 and 2. But we are solving for x, so we are saying, but m is equals to log 5 base x. So let's take this back into the equation. So we are saying log 5 base x is equals to 1, or log 5 base x is equals to 2. By the definition of logarithms, we can rewrite this one in index form as x to the power 1 is equals to 5. At the same time, this one is x to the power 2 is equals to 5 as well. So like this. So we are now, we are done with this, with the first one. So we are now solving this quadratic equation, x squared is equals to 5, right? So we are applying the square root. Please note that we are taking the positive. We have x squared is equals to 5. When you apply the square root, we find plus or minus, but we are taking the positive only since we are in the set of real numbers. Remember, this is the base of this logarithm, so we can't have a base which is negative, so we are taking positive root 5 only, and that's our answer. Thank you very much for watching. Please don't forget to subscribe, like, and share our videos.